Hello guys, today I'm gonna solve mechanics 1 question for you. It's question 1 from paper 4-2 May June 2019. The question is about forces and systems in equilibrium. So in this question we have 4 coplanar forces that act at the point in the directions shown in the diagram. The system is in equilibrium and we have to find the values of P and theta. The first thing that you have to do when you see questions like this is to resolve forces into components and then resolve the forces horizontally and vertically. So let's resolve the forces into components. I'm going to resolve the 32 newtons and we have here 32 cos 20, the vertical component, which is gonna be 32 sin 20. Let's resolve the P newtons force, the vertical component over here, which is P sin theta, the horizontal, which is P cos theta. And now let's resolve the 17 newtons. The vertical component over here, it's 17 cos 55, and the horizontal, it's right here, is gonna be 17 sin 55. And now once this step is done, this is the first step and the most important step, now is to resolve the forces horizontally and then resolve the forces vertically. So resolving forces horizontally, it means that the resultant force horizontally is 0, which means the sum of the forces acting to the right is equal to the sum of the forces acting to the left. So we have 32 cos 20 should be equal to 17 sin 55 plus P cos theta. And I'm going to do the same thing vertically. The sum of the forces acting upwards, 40 plus 17 cos 55 is equal to the sum of the forces acting downwards, P sin theta plus 32 sin 20. And now this step is done. You can solve the two equations for the two unknowns. So I am going to start by rearranging these two equations. So P sin theta is equal to 40 plus 17 cos 55 minus 32 sin 20. I'm going to do the same for P cos theta, which is equal to 32 cos 20 minus 17 sin 55. And now once you have these two relations, the easiest thing to do is to divide the two relations. So you basically gonna divide the P sin theta over P cos theta equals to 40 plus 17 cos 55 minus 32 sin 20 all over P cos theta, which is equal to 32 cos 20 minus 17 sin 55. Now, as you can see, P over here cancels out and sin theta over cos theta is tan theta. So your tan theta is going to be 40 plus 17 cos 55 minus 32 sin 20 over 32 cos 20 minus 17 sin 55. And now on your calculator, theta is going to be tan minus 1 of all of these relation, and that's when you put everything on your calculator and get the final answer. Now it's important to remember that you shouldn't do any rounding until you get to the final answer. So this is why I advise you not to do any calculations until you get to the final relation from where you can get your final answer. Sometimes it's not possible, so you will have to do some calculations, but then like in questions like this one, you can do that. So now on your calculator, just tap tan minus 1 of all of this relation from above, and you should get the angle as 67.4 degrees. Remember, your angles should be given to one decimal place. Now once you have the angle, is easy, you go in one of the relations. Let's go on the second one. So P is gonna be 32 cos 20 minus 17 sin 55 over cos 67.4, and your answer should be 42.0 newtons. And this question is going to give you 6 marks in the exam. Thank you for watching.